Welcome to the session. In this session, we are going to see the topic of poles and residues. Okay? We are going to see what is the formula to find the poles. If we can find a positive integer n such that limit z tends to a, z minus a to the power n, f of z which is not equal to 0, then z equal to a is called the pole of order n for f of z. Next, we are going to find the residue of the given function. If it is simple pole, what are all the formulas? And if it is a pole of order more than one, multiple pole, that is order 2, 3 or next, we'll see some other formula. So first, if it is having the pole of order 1, then the formula is residue of f of z is equal to limit z tends to a, z minus a into f of z. Next, if the f of z in the form h of z by g of z, where z is equal to a is a simple pole. Here, if we got the answer h of a which is not equal to 0 and g of a is equal to 0, then the formula is limit z tends to a, z minus a into f of z, h of a divided by g dash of a. Next, if it is a pole of order m, multiple pole, residue of f of z tends to a, 1 by m minus 1 factorial, limit z tends to a, d m minus 1 by dz of m minus 1, z minus a to the power m into f of z. We'll see some of the formulas. Problems related to the topic. Find the residue of the function f of z is equal to z by z square plus 1. First of all, we have to find the poles. To find the pole, we have to find the denominator term of f of z. Here f of z it is given as z by z square plus 1. So to find the pole, the denominator term which is equal to 0, z square plus 1 which is equal to 0. From that, z square which is equal to minus 1, z which is equal to plus or minus I. So we got the answer z is equal to I and minus I, and both are simple poles. Simple poles. Next, we are going to find what is the residue of a simple pole. So residue of f of z for the z tends to a which is equal to limit z tends to a, z minus a into f of z. This is the formula here, which is equal to, I am going to take limit z tends to I. For the I am going to calculate what is the residue. So limit z tends to, this is residue of f of z for the function f of z, that is I is equal pole which is equal to I. Limit z tends to I, z minus I into the f of z we are having is z by z square plus 1. So from that, limit z tends to I, z minus I, z by, I am going to write z square plus 1 as z plus I into z minus I. So cancel these two. So I got the answer limit z tends to I, z by z plus I. So if we apply the limit, I got the answer z by I by 2I which is equal to 1 by 2. That is the answer. So if in the case of minus I, residue of f of z tends to minus I which is equal to z minus of minus I. So plus I into f of z. F of z here is z by z plus I into z minus I. So here the term it gets cancelled. I'm going to apply the limit z is equal to minus I. So if I substitute minus I divided by minus I which is equal to minus I divided by minus 2I which is equal to 1 by 2. So finally I got the answer. Poles are simple poles. Simple poles is equal to I and minus I, and residue R1 is equal to 1 by 2 and R2 which is equal to 1 by 2, that is corresponding to I and minus I. Next we will see some other problems.